For many years, the Hermes Society has had an issue with the public at large, not believing the adventures of Otto Lindenbrock and his team during their journey to the center of the Earth. The main focus here will be analyzing their final climactic voyage, in which the team is thrust from the Earth's center by a volcanic eruption as they ride upon a raft. In order to provide the public with evidence to prove the factuality of the Grand Escape, they approached the realm of physics, particularly fluid dynamics. Fluid dynamics deals with fluid flow, the natural science of fluids in motion, and where one would have to look in order to solve this problem.
Fluid dynamics has several subdisciplines, including aerodynamics, the study of air and other gases in motion, and hydrodynamics, the study of liquids in motion. It has a wide range of applications, determining the mass flow rate of petroleum through pipelines, predicting weather patterns, and even helping to understand volcanic reactions. Fluid dynamics serves as the foundation of these principles. Founded on flow measurement, it is used to solve a myriad of practical problems. The way we would find the solution to a fluid dynamics problem would be to calculate various properties about the fluid, such as the pressure, density, temperature, and velocity. An example of this would be the perfect gas equation of state. Through this, we can examine Professor Otto Lindenbrock and his team's outrageous raft ride.
The formation of geysers is due to particular hydrogeological conditions, which exist in only a few places on Earth, so they are a fairly rare phenomenon. Generally, all geyser field sites are located near active volcanic areas, and the geyser effect is due to the proximity of magma. The boiling point of the pressurized water results in the geyser effect of hot water and steam spraying out of the geyser's surface vent, a hypothermal explosion.
I did some calculations using the perfect gas equation of state, and found that if I place a squirrel onto a piece of bark and place it on top of an erupting geyser, it will sustain the same effects as Otto and Company, and with a proportional ratio. The pressure that will be put upon the squirrel is directly equivalent to what the explorers underwent on their journey from the center of the Earth. While the geyser will not be powered by a volcanic eruption, the amount of water that poured into the lava will react in such a way that they are ultimately equivalent. While most people would imagine something horrible happening to the squirrel, he's simply in a state of intense shock. He may not look quite like himself at the moment, but in the matter of his health, he's absolutely fine. Once over the shock, he'll relax and walk away without any part of his life having been affected. When approached with this issue, I was very excited about the topic because I was not quite sure which outcome I foresaw as being more likely. From a rationalist point of view, I cannot conceive of people surviving such an event, but through findings of my research and experiment, my mind was swayed. After comparing all the data that I've compiled, it is more comfortable for me to say that this event is definitely possible, rather than to leave it open to any sort of debate.